Expanding and factorising are two techniques that are going to be very useful throughout the Maths A level. Whether you have some expressions in brackets that have been times together and you want to work out what that multiplication would be, or you have a larger polynomial, that is to say an expression consisting of multiple terms, maybe of x, but each x term is to a different power, and you want to break these down into brackets that would have times together to make it. And then from here we can solve for what x values would make this true. Starting with the expanding, if say we started with a bracket like this and you just had a single term on the outside, all you would do is you would take this term on the outside and multiply each term inside the bracket respectively by it. So here for 3, then brackets x plus 4, that'll be 3 times x is 3x, and 3 times 4 will be 12, so 3x plus 12. Alternatively, if you had two brackets both times together, what we're going to want to do is multiply each term in the left-hand bracket by each term in the right-hand bracket. And to make sure that we do every single one of these multiplications, there's an acronym we can use to follow to say, okay, we've times this by this, and so forth. This acronym is FOIL, where FOIL stands for first, outer, inner, and last, which means in this case, okay, we'll do the first term by the first term. So x times 9 will give 9x squared, and outer means the far left times by the far right, the outside number, so x times minus 2 will be minus 2x. Inner is the inside 2, so that's 5 times 9x, so that will be 45x. And then lastly, last 2, so 5 times minus 2 is minus 10. We can then just bring the like terms together in the middle to have 9x squared, and then minus 2x plus 45x is going to be 43x, and then, yeah, still plus 10 at the end. If we're in a situation where there's 3 brackets that you need to times together, what I would suggest doing is doing 2 brackets first and then timesing by the other bracket afterwards. So for instance, in this case, still using FOIL, we'll have so 6 times 3x will be 18x, 6 times minus 5 is going to be minus 30, 5x times 3x is going to be 15x squared, and then 5x times minus 5 is going to be minus 25x. Rewriting this now in brackets and in order of descending powers, so 15x squared, the 18x minus the 25x is going to leave us with minus 7x, and then here's going to be minus 30. This now has been times by that bracket there, and just as how we did every term by every term before, we're going to do that same thing again. It's just going to be a few more steps this time. So 15x squared times 8x is going to give us 120x cubed. 15x squared then times the 9 is going to give you 135x squared. Moving on to the second term in this left-hand bracket, minus 7x times 8x is going to be minus 56x squared, and minus 7x times 9 is going to be minus 63x. The final term then, minus 30 times 8x is going to be minus 240x, and minus 30 times 9 is minus 270. Just once again, bringing the like terms together, we'll then have 120x cubed, 135x squared minus 56x squared is going to leave us with 79x squared, then minus 63x minus 240x is going to be minus 303x, and finally that's just your minus 270. Now if instead, as I suggested, we start with the polynomial, we'll start with a quadratic here, and we want to break it down now into those brackets that we just had above when we were beginning. Well, here it's going to break down into 2 brackets because we have here 3 terms. These brackets are going to start with x and x because x times x is x squared. Now to work out what goes in the ends of the brackets, these two numbers need to times together to make 63, and then add together to make the 16. So times to make the last number, add to make the middle number. For the factors of 63, we have 7 and 9. So if we just put a 7 here and a 9 here, and then to make it a 16, a plus 16 in the middle, we'll have a plus 7 and a plus 9. Now if instead we'd had here x squared minus x minus 6, again, we're going to have two brackets that start with x. Here, we're going to have numbers that times together. Now you could have 1 and 6 or 2 and 3. But considering that we're then going to want to make a minus 1 in the middle, we'll choose the factors to start off with that are closest together. That would be the 2 and the 3. So we've got a 2 here and a 3 here. But as to what signs to put in here, again, if we want a minus 1, what we can say is that will be a plus 2 and a minus 3. So 2 minus 3 minus 1. This also works because here a plus number times a minus number is going to give you a minus at the end. So actually what we can tell about the signs from the initial quadratic is if it's a plus here for the final term, that tells us the signs are the same. Not that they're necessarily both pluses, they could be both minuses as well, but they're just the same because plus times a plus is a plus, minus times a minus is a plus. But if it's then a negative here, then that means they're opposite signs. For a third example, if we actually had a different coefficient other than 1 in front of the x squared, we'd have to do something slightly different. We're again going to have our two brackets, but here we'll have to say it's 2x and x because they would times together to get 2x squared. Now the problem is that when we expand this, whatever number is here on the far right is going to be multiplied by the 2 when we're making the middle term here. It's like how in the example above, when we had our 9x, the 9x turns the 5 into a 45. So when we think about our factors of 18, so you're going to have 1 and 18, 2 and 9, and 3 and 6. One of these numbers is going to be times by 2. So that either means this is going to become 1 and 36, 2 and 18, or 3 and 12. Could any of these pairs make minus 12 in the middle? No, they couldn't. They couldn't plus or minus to make that. So it's not going to be any of these that are times by 2. So what if on this side they're times by 2? So you now have 18 and 2, 9 and 4, or 6 and 6. Oh yes, it's the 6 and the 6 can make the 12. So remember to use the original number here, the 3. So the 3 is being times by the 2, so it has to go on the right. That puts a 6 here. We have, again, a minus and a minus to make minus 12. We just want to double check. 2x times x is 2x squared. 2x times minus 3 is minus 6x. Minus 6 times x is minus 6x. So together, minus 6x minus 6x minus 12. Minus 6 times minus 3, well, the minus times the minus makes a plus, and 6 times 3 is 18. This works. Now again, I just want to reiterate that this double bracket factorising is just if you have like the 3-term quadratic. If you're missing any one of the terms, let's say you're missing the 18 here, and you just had the 2x squared minus 12x. All you could do was take out a common factor. So in this case, from the numbers, you can take a common factor of 2, and then from the x's, you can take a common factor of x. So 2x squared divided by 2x will just leave you with x, and minus 12x divided by 2x would leave you with minus 6. So you end up with something like the very first example we had. Or if you were missing the middle term, so we just had 2x squared plus 18, all you could take out would have been the factor of 2. So you'd have 2 in bracket x squared plus 9. With all of these though, there's actually something else that we can do, which is to say that we will solve. We'll solve if these equations equaled to 0. If they didn't equal to 0, then we'll just need to bring everything round onto the same side and collect like terms if needs be. But with this equaling 0, we're now saying that these multiplied brackets also equal 0. And if two things times together to equal 0, one of them must be 0 in itself. So we're either going to have that x plus 7 equals 0, or x plus 9 equals 0. And moving the numbers over to get x on its own, we therefore have x equals minus 7 or minus 9. In this case here, you'd end up with x is minus 2 or positive 3, because if 3 minus 3 would give the 0. And then here, if you have a coefficient, you'd also be dividing by that. So, okay, so 2x minus 6 equals 0, add the 6 over, so 2x equals 6, therefore x is going to equal 3. Then here as well, though, x would equal 3. So there is only one solution here. If it says solve, it has to equal 0, and then you have to make this final step of making each bracket or factor equal to 0 itself and find, well, what x value would make that true. Before we get on to some actual questions, there's one other thing I want to discuss, and this is called the quadratic formula. This is what we can use to work out the values of x if we can't nicely break these quadratic down into two brackets. Either we just can't spot what the numbers are, or in actuality there are no whole numbers that will work for it. Our general formula for a quadratic is going to be ax squared plus bx plus c, where a is then the coefficient of your x squared, b is the coefficient of the x term, and c is the number that's on its own. If this equals 0, we can say that x equals minus b plus or minus, this here just saying we're going to do it once with a plus to get one answer, and then do it again with a minus to get another answer. The square root of b squared minus 4ac all over 2a. So if we were to come up with an example here, let's just say 6x squared plus 2x minus 6 equals 0. Our b term is 2. So it'd start off with minus 2 plus or minus square root of 2 squared. Now I'm putting this here in brackets before squaring just because it's good practice. It doesn't make a difference here because this b value is positive. But if b was negative, you'd want to put it in brackets before squaring so that your calculator does things in the right order. You want it to be the negative that's being squared, not squared and then have a minus put on afterwards. It does make a difference. And then we'll have minus 4 times your a is 6 and your c is minus 6. And this is all over 2 times 6. Now we have that, you just plug it in the calculator, and let's say giving our answers to 3 significant figures, you ended up with x equals 0.847 or minus 1.18. As we can see, therefore, these are rather precise x answers. We wouldn't have found those by putting them into 2 brackets unless it would have occurred to you to try to 3 decimal places with your factors. If this is all good, let's just see how we get along with questions of our own. First of all, I would like to see if you can expand 4x, and brackets 3x squared minus 3x plus 8, and then solve x squared plus 3x minus 2 equals 0, 4x squared minus 4x minus 63 equals 0, and then 81x squared minus 25 equals 0. Think over what we've been talking about with the different techniques for expanding and factorising depending on what's necessary. Pause the video, have a go for yourself, and then press play again when you're ready to compare. Okay, so with this first one, even though it may look like these are small, simple numbers, this will in fact not go into 2 brackets. Your factors of 2 are going to be, well, 1 and 2. And while you could add the 1 and the 2 to make your 3, because this is a minus here, like we had down here, that's telling us that we have different signs. Either you're going to have x plus 1 and x minus 2, or x minus 1 and x plus 2. Either way, you're not actually going to be able to make them be 3 in the middle. so we have to use the quadratic formula again. Now, if in fact we had made a misjudgment here, in fact it was possible to do it in 2 brackets, really doesn't matter, the quadratic formula will get you the exact same answers, it's just about whichever is quicker for you. So just without plugging this in here, your b is going to be 3, so minus 3 plus or minus the square root of 3 squared minus 4 times 1. If there's no coefficient here, just think of it as 1 times minus 2. And then that's going to be over 2 times 1. So from this, you get x equals, again, let's say 3 significant figures, 0.562 or minus 3.56. Just proof that, yes, in this case, we would have had to have used the quadratic formula here. Secondly, this one does actually go into 2 brackets. Once again, there's no issue using quadratic formula if you want here. But if you were doing it for the 2 bracket method, in this case, with the 4x, unlike here when 2x squared had to be either 2x and x, there's no other way of splitting it, 4x squared can either be x and 4x squared, or 2x squared and 2x squared. What I'm going to suggest trying first is going with them being the same as each other. So let's say we'll go with 2x and 2x. That's the alphabet prematurely. Then here, that means that whatever factors you come up with to make the 63, they're both going to be doubled when you make your middle term. What we can also say here is because this is a minus, one of these is going to be plus, one of these is going to be minus. Going through your factors of 63, therefore, you're either going to have 1 and 63, 3 and 21, or 7 and 9. They are only options. In each case, therefore, because you will be doubling both, you're either going to have 2 and 126, 6 and 42, or 14 and 18. In general, because this is a, relatively speaking, small number in the middle, I would again suggest going by the 2 numbers that are closest to each other, so the 7 and the 9. But either way, we can see here that 14 and 18, they can be used to make minus 4. If you have a plus 14 and a minus 18, so here, don't forget, we're using the original actual factors though, so it's going to be a plus 7 and a minus 9. To solve then, we have 2x plus 7 equals 0. So if you were to minus the 7 over, 2x equals minus 7. So x equals minus 7 over 2. And then here, 2x minus 9 equals 0. So add the 9 over, 2x equals 9. So x will equal 9 over 2. Lastly, now this one is different again because we are missing one of the terms. We don't have all 3 terms. Yet at the same time, there's no common factor we can take out here. So actually what we are going to do is we are going to still make it a double bracket. We're going to refer to this as the difference of 2 squares. Basically, if you have 2 square terms that are minused from each other, they have to both be squares and they have to be minused. What we can say is that it's like the square root of each number plussed in one case and minused in the other case. So the square root of 81x squared is going to be 9x. So I have 9x at the start of each bracket. And the square root of 25 is 5. So I have a plus 5 and a minus 5. If you just want to double check that this works, 9x times 9x, well 9 times 9 is 81, x times x is x squared. 9x times minus 5 will be minus 45x. 5 times 9x will be plus 45x. Minus 45x plus 45x is going to cancel to be nothing. That's why there's no middle term. And then 5 times minus 5 is minus 25. At this stage then, we just have yet again the same principle. So x will either equal, or it should just equal plus or minus 5 over 9. At this stage, I will just say, depending on what calculator you have, you may have a function which actually solves polynomials for you. If you do, then all you have to do is plug in the coefficients of each of the x terms, depending on what powers you have, and you just plug it in and it will give it for you. But if you're unsure of where this function is on your calculator, or you don't have it, or you just want to work things through manually on the page anyway, then these are the techniques that you'll be using. Before we wrap up though, there's one other thing I just want to mention. What if we had to factorise a larger polynomial? What if we had to factorise this here, which is a cubic? Well, for this, we're going to employ something called the factor theorem. That is to say, if we found an x value that caused the whole expression y to equal 0, then x minus that number would be a factor of it. Once we have the factor, we can then go about dividing that factor out to leave us with a quadratic, and then that quadratic we could solve on our own. To test for what x values make this equal 0, I would suggest starting from like 1. I mean, you can start from 0 if you want, but if you put these x's equal 0, you're just going to be left with minus 48. That clearly doesn't equal 0 overall. So if we were to try, say x equals 1, that in this case will get you that y is minus 21. That doesn't equal 0, so we won't go with that. Next, I would actually alternate to the negative as well. So x equals minus 1. Well, that's now going to get you that y is minus 11. Again, that doesn't work. X equals 2 now. You get y is 160. Nope, still not working. And finally, x equals minus 2. Yep, that now makes it equal 0. X equals minus 2. If your a is minus 2, therefore, that we can say that x minus minus 2, or in other words, x plus 2, is a factor. In fairness, usually in these questions, it will give you exactly what the first factor is, and you just have to test that it's a factor. So if, say, they've given you x plus 2 to begin with is a factor, you say, okay, if x plus 2 is a factor, then x itself must equal minus 2, because you're looking for the bracket to equal 0. You then put in x as minus 2 in here, and you would show that it equals 0. It's only if it doesn't give you what the factor is that you'll then do this kind of trial and error method. Once we have this factor identified, we can then use a couple of different methods to say get that remaining quadratic if you were to divide it away. One method would be trial and error, just to keep on trying more x values, but because you don't know what they are, you don't know how high you're going to get, or indeed if you're going to need fractions, that may just take far too long. So what I would personally suggest, my choice of method, is something called long division, where we'll say we'll take this x plus 2 and we'll divide the whole cubic expression by it. So then we just have here minus 20x minus 48. How long division works is we'll say, okay, what would you have if you had 15x cubed divided by x? Well, that would leave you with 15x squared. Now, we'll say, well, what would be the whole factor times by the 15x squared be? Well, x times 15x squared is that 15x cubed again, but then 2 times the 15x squared would give us plus 30x squared. At this stage, we're going to minus these two expressions from each other. So the 15x cubed minus 15x cubed cancels. The first one should always cancel. And then 32x squared minus 30x squared is just 2x squared. I'll bring the minus 20x down. So again, we have two terms we're going to be looking at. And we'll start again. So 2x squared divided by x, that's just going to be 2x. And there's 2x times the whole thing. So 2x times x is 2x squared. And 2 times 2x, 4x. Once again, we'll take these equations away from each other. So 2x squared minus 2x squared disappears. Minus 20x minus 4x, then minus 24x. Bring the minus 48 down and start again. One more time. Minus 24x divided by x is minus 24. Then minus 24 times the whole expression. Yeah, minus 24x minus 48. These will then all cancel with each other, because then minus 24x minus minus 24x minus minus is like plus. The plus and minus make it disappear. Exact same with the 48s, leaving you with 0. If this didn't equal 0 here, something has gone wrong. This isn't an exact factor. Either somewhere in your long division you've gone wrong, or this wasn't actually a factor to begin with. Either way though, in this case, we now have that this is our other quadratic, And with this, you could either use the quadratic formula or split it into two brackets like you did before, and then from those you can get your x solutions. If you wanted an alternative to long division though, you can use an algebraic method to say that, okay, so you've got x plus 2, and then if you were to take this out of this cubic, you would be left with a quadratic. The first terms would have to times together to make the first term here. So you would have to start with 15x squared, because x times 15x squared would make 15x cubed. We don't, however, know what the middle term is going to be, so it's just going to be some unknown bx. And then at the end, we know the last terms have to times together to make the final term here. So if this is 2, this must be minus 24, because 2 times minus 24 is minus 48. Expanding these brackets now, so x times 15x squared will be the 15x cubed, x times bx will be bx squared, and x times minus 24 is minus 24x. And 2 times 15x squared is 30x squared. 2 times bx is 2bx, and 2 times minus 24 is the minus 48. 15x cubed, check. Minus 48, check. Bringing now together the like terms, you'd have bx squared plus 30x squared. Given that these expressions are supposed to be the same as each other, this must be the same as the x squared term from here, so the 32x squared. Or if you want to look at the single x term instead, minus 24x plus 2bx, that must be the same as the minus 20x here. Either way, you would end up with b being 2. Thus, the quadratic here is actually 15x squared plus 2x minus 24, same as what we had from the long division, and just like with that, we can now factorise or quadratic formula and solve. That's all we need to do if you have a larger polynomial, such as a cubic.